Climate change is one of the most pressing challenges of our time. From rising temperatures to shrinking ice sheets, the impacts are visible across the globe. But how do we monitor these changes? How do we keep track of the Earth's vital signs? Welcome to this video on remote sensing for climate change studies. Remote sensing is a powerful tool that allows us to observe and monitor the Earth from space, providing critical data that helps us understand and address climate change. With satellites orbiting high above, we can collect information on temperature, sea levels, ice cover, and much more, offering a comprehensive view of how our planet is changing. Remote sensing involves the use of satellites equipped with various sensors to capture data about the Earth's surface and atmosphere. These sensors can detect a wide range of electromagnetic radiation, from visible light to thermal infrared and microwave signals. This data is then processed to create detailed images and maps that scientists can analyze. Optical sensors capture images similar to what our eyes see, while thermal sensors detect heat emitted by the Earth's surface. Synthetic aperture radar, or SAR, uses microwave signals to penetrate clouds and vegetation, providing valuable data even in challenging conditions. Remote sensing allows us to monitor key climate indicators that tell us how our planet is changing. First, let's look at temperature changes. Thermal infrared sensors on satellites measure land and sea surface temperatures, helping us track global warming trends. With time series data, we can observe how temperatures have risen over decades. Next, sea level rise. Satellites equipped with radar altimeters measure the height of the sea surface, giving us insights into how melting ice and thermal expansion of seawater are contributing to rising sea levels. Remote sensing is also crucial for monitoring glaciers and ice sheets. By analyzing images from SAR and optical sensors, we can track the extent and thickness of ice, providing clear evidence of glacial retreat in regions like Greenland and Antarctica. Vegetation and land cover changes are another critical indicator. Using indices like NDVI, remote sensing helps us monitor deforestation, desertification, and vegetation health. This data is vital for understanding how land use changes impact carbon sequestration and climate regulation. And finally, atmospheric composition. Satellites monitor greenhouse gases like CO2 and methane, as well as aerosols, which play a significant role in the Earth's radiative balance and climate. Let's take a look at how remote sensing is applied in real-world climate change studies. Case Study 1, the Amazon rainforest. Remote sensing data is used extensively to monitor deforestation rates. By analyzing changes in forest cover over time, we can assess the impact on carbon emissions and biodiversity. Case Study 2, Arctic sea ice decline. Satellites have provided clear evidence of the dramatic decline in Arctic sea ice over the past few decades. This data is crucial for understanding the implications of melting ice on global climate patterns. Case Study 3, Coral bleaching events. Remote sensing is used to detect and monitor coral bleaching, a phenomenon driven by rising ocean temperatures. This data helps in assessing the health of coral reefs and planning conservation efforts. The future of remote sensing in climate change studies is bright. With advancements in technology, we are seeing higher resolution data, more frequent observations, and the integration of AI for automated analysis. These innovations are making it easier for scientists to monitor and predict climate changes with greater accuracy. International collaborations and open data initiatives are also playing a crucial role, enabling researchers worldwide to access and share vital remote sensing data, driving forward climate research and informed decision-making. In conclusion, remote sensing is an indispensable tool in the fight against climate change. By monitoring the Earth's vital signs, we gain the knowledge needed to protect our planet and ensure a sustainable future. The data we gather from space is not just information, it's a call to action for policymakers, scientists, and every one of us. The data we gather from space is not just information, it's a call to action for policymakers, scientists, and every one of us.